Recording in progress.
Using fundamental identities. What does it mean, the word identities? Basically, those kind of formulas, they connected together and has a meaning. Like when we say sine square theta plus sine square plus cosine square theta equal 1, this is called identity. Okay, this is called identity. When I say cosecant of theta equal 1 over sine theta, this is identity. So basically it's formulas. That's the meaning, is a formulas. We're gonna see a lot of them. Do you have, how shall I print the formula sheets? Did you print the second formula sheet? That's okay. All right. You can see this is the first set of formulas. We know some of them already. We know that cosecant is inverse of sine. Sine is also inverse of cosecant. They cannot relate it together. So you can see here, this saying sine equal inverse of cosecant and cosecant inverse of sine. That's same meaning. Same thing in here. We have cosine inverse of the secant. Okay. And the secant is inverse of cosine. Well, normally I memorize the bottom one. The top one I know. So cotangent is inverse of tangent. However, also tangent, it's important to remember, is a ratio of sine over cosine. Cotangent is cosine over sine. That's important to remember. The other one that's all from from chapter 4. Sine square plus cosine square equal 1. 1 plus tangent square equals secant square, or 1 over cosine square. 1 plus cotangent square equal cosecant square, or 1 over sine square. Okay, this is from chapter 4. The new identities, they call it confuction identities. Actually, we looked at this one. Yes, we did. That's nothing new. When we say sine pi over 2 minus u, that's equal to cosine of u. Remember when we have that, even like if you look in the triangle, if you have here an angle is u, and this one here, how much is this one? This is pi over 2 minus u, right? Because both of them, they equal to 90. This is pi over 2. If this is u and this pi over 2, then this pi, or pi over 2 minus u. Then if I say sine of u Also that's equal cosine of pi over 2 minus u. If I say cosine of u, that's equal sine of pi over 2 minus u. I think that's the same thing in here, right? Yeah, see, sine of u equal cosine pi over 2 minus u. Or cosine of u is equal sine pi over 2 minus u. How do you verify these? Basically, because when we say sine of u, opposite over hypotenuse, right? And we look at this angle, it's also opposite over hypotenuse. We kind of look at it before. Okay, tangent the same way. Tangent, you can figure it out from dividing sine over cosine. Is going to be tangent pi minus u equal cotangent of u. Cotangent of pi over 2 minus u is equal tangent. Secant pi over 2 minus u is equal cosecant of u. The only way we can understand this, you are not going to memorize anything. You are in formula sheet. We're going to solve a problem. By practice, we understand how to use them. Even an odd identity. Sine negative of u equal negative sine of u. Cosine of negative u is equal cosine of u. Then there is the tangent. You take the ratio and you figure it out. We did look at this one too. So everything is from chapter 4, honestly. So again, like in your we looked at it from the circle point of view. If this is the cosine axis, and this is the sine axis, okay? If I have an angle here, I call it u, then I have an angle down here, same amount, negative u. Those two angles, they have the same cosine, correct? Same cosine. You have to predict, because this is your horizontal axis, where they have opposite. Sine of u equal negative sine of negative u, or vice versa. So sine of negative u equal negative sine, because this is a positive and this is a negative. A lot of time you can go back to the circle, make you understand what's going on. You plot u and you plot negative u. Oh, same cosine. The sign is opposite. Tangent, you don't need to worry about the tangent. Tangent of negative u is equal sine of negative u over cosine of negative u. You divide them by each other, you get the answer. So basically, because the sign is negative, tangent negative of u is going to be negative tangent u. And the cotangent, the cosecant and secant in the same manner. Thygorium and identities. Where does this come from? Do you remember where it come from? This one here, remember, we have sine square of u plus cosine square of u equal 1. Then sine of u square equal 1 minus cosine square of u. Then sine itself, no square, equal positive negative square root of 1 minus cosine square of u. And that's what they. So basically, it's not a new things we already know. Same thing for the tangent. Remember, we have 1 plus tangent square of u equal secant square of u. Or the other way around. What was it? Let me go back and look at that. I don't remember it. Yeah, here it goes. You have 1 plus tangent equals secant. Okay, that's what I wrote. Yeah, so that's the original one. So if I say tangent square u, that equals secant square of u minus 1, then tangent of u equal positive negative square root of secant square u minus 1. So this is nothing new. This is from the previous ones. Using fundamental identity. How do we use them? That's the key. Can skip the other ones. Simplify. We did something like that in chapter 4. How do you simplify? You write what you know. What do I know? I know something. This is a sine and this is sine. What happened if I convert the cosine square into sine? Doesn't that make the problem? Maybe that's the root, right? We know that cosine square of x equal 1 minus sine square of x, correct? That's from the identity sine plus sine square equal 1. Okay, so that's sine square plus cosine square equal 1. From here, we get cosine square x equal 1 minus square x. So let's plug in sine x multiplied by 1 minus sine square of x minus sine of x equal. Just replace the cosine square. Distribute sine x multiplied by 1 minus sine x multiplied by sine x square, the sine cube of x minus sine x. Any questions so far here? All what I did, replace cosine square by 1 minus sine square. Plug it in, distribute. Now sine minus sine, they cancel out. So the final answer is negative sine cube x. I think that's the simplest possible. The only thing they say is simplify. That's it. So same answer. Now it said rewrite so that there is no fraction. So there has to be the answer on the line. Now it is a fraction. How do I get as a fraction? What do I do to get rid of the fraction? I don't know if we solved some problem before. Remember the conjugate? What is conjugate in imaginary numbers? When we divided imaginary over imaginary, we multiply by the conjugate at the bottom, top and bottom. So the conjugate will flip the sign in the middle, right?
So it would be 1 over 1 plus sin x times the bottom, which is flipped, right?
Yes, so you multiply top and bottom. It's not really, it's similar to conjugate. You say 1 minus sine x over 1 minus sine of x. It's like nothing happened. Why do we do that? Because remember the formula that a square minus b square equal a minus b multiplied by a plus b. So you need to remember this formula. And you can go backward. So I have 1 plus multiplied by 1 minus. So what's going to happen in the bottom? You're going to have 1 square minus sine square of x. That's correct. Then on the top, we're going to have 1 minus sine of x. So 1 minus sine square of x, what equal to? Just here, did it in. That's right. So we have this one is 1 minus sine of x over cosine square of x. Well, 1 over cosine of x. Inverse of what? Secant, very good. Secant x, correct? So if I replace, and if I make a square, square and square, then this answer is going to be 1 minus sine of x multiplied by secant square of x. Do we have a fraction? No. No more fraction. Well, they did it a little bit different in here. I mean, they're gonna get same answer. I think that's very lengthy. See, from here, what they did, you know, what I gave you is a good answer. So what they did, they said 1 over cosine square They said 1 over cosine square x minus sine x of sine square x. I wouldn't do that. That's too lengthy. Then this is become secant square x minus, you can split the cosine, it's become tangent x multiplied by secant of x. That's the same answer we got. See, because if you move the secant square to inside, you're gonna get back same answer. But up to this point, that's good enough. But it's good to know. So the book like to do it a little bit different. Okay, section 1 is over. They are very short sections, so it's not like the previous chapter 4 was very long. Verifying a trigonometric identity. So if sine x equals 0, what is x? X is equal n pi. Y is n pi, where n equals 0, 1, 2, etc. Could be any numbers. So if it's 0, then the x is 0. If it's 1, it's pi. 2 is 2 pi. Again, you can go back to the circle to understand why. If we have the x-axis as a cosine, remember x is always equal to cosine. X equal cosine, y equal sine. Then, and this is, at this point, this is 0. This is a unit circle. This is positive 1. Oh, no, well, let me write it as a coordinate. This is 0, 1 comma 0. That's a coordinate. And this one here, 0 comma 1. This point here is negative 1 comma 0. And here is x is still 0 comma negative 1. So remember, the first number is the sine, the coordinate. This is equal sine comma cosine. No, the other way around, sorry. Cosine comma sine. So always first number is the cosine. The second number is the sine, okay? So let's look at, if this is 0, if the x equals 0, this is x equals 0. What's the angle at this location? And y equal 1. I mean, so sine equal 1. So this is different. Well, this is sine equal 1. Sine is not 0. Where is the sine 0? Ah, at this location. At this point, If x equal 1, which is a cosine, y equals 0. So what the angle was? 0. Here's the 0 angle. Theta equals 0. Now, if I go all the way around, the angle here is pi. So also, the sign is 0. So basically, the sign always 0, either 0 or pi. We go back to here, is 2 pi. So that's the reason we said m pi. So the angle is 0, the sign is 0. Angle is pi, is still 0. The angle is 2 pi, 0. 3 pi, 0. 4 pi, 0. Okay? That's where it comes from. So kind of like you have to mix everything together. X equal cosine, y equals sine. This is the angle 0. This is the angle pi over 2. This is the angle pi. This is 3 pi over 2. So I have 3 circles on top of each other. Unit circle, angles, sine, cosine, but they all work in the same way. They solve what is the x? Solve for x. Well, no, what is this? This sign, this is, we know this one. This is identity. Let's see what they want. Well, this is just identity. Okay, they have another question about verifying this. Now, how do I start? Tell me, Maria, how do I start? Okay. I'll tell you what the answer. Just write what you know. What do you know about the secant? Can I tell you what do you know about the secant? What do you know about the secant, Tara? That's correct. Oh, that's what I know. Do I know anything else? Not yet. I'm going to leave this alone, the sine square, because I wanted to prove this is correct. Prove. So you don't touch this one. Prove. All what I have to work here. The only thing I know at this stage is that the secant equal 1 over cosine. That's the only thing I know. So let's put it there. So we're going to have 1 over cosine square theta minus 1 over 1 over cosine square theta. Now, from that point, what should I do? Well, I need to try to, well, one thing, you can convert this to multiplication of the flip of the bottom. That's still, I can say 1 over cosine square theta minus 1 multiplied by cosine square theta over 1. So you multiply by the flip of the bottom. Remember, when we have A over B divided by C over D, this is equal A over B multiplied by D over C. Flip of the bottom. Okay. Now, distribute to inside. You get cosine square theta over cosine square theta minus cosine square theta, just by moving this to inside. Now, what's this equal to? 1 minus cosine square theta. Now, Maria, what do you know about 1 minus cosine square theta? Do you remember the identity? Sine square plus cosine square equal what? Equal 1, right? So 1 minus cosine square, what is equal to? Equal sine square. So this one equal sine square theta, check mark. So it really, that's not too hard. All what you have to do, just put what you know. You have your formula sheet, you look, okay, what formula I can use, and just go from there. Go step by step until you get the answer. So that's the reason I'm asking you always in the test, write the process. If at the end you do mistakes, still I know you did the process. Again, they solve it different ways. Yeah, I wasn't looking even. Excuse me? I don't know. I mean, this is a different way. You know, I think the way I did it much easier. Because this one here on the top, the secant square is equal tangent square plus 1. So this way, if you don't remember it, I don't remember this a lot. So then you get only tangent square over secant square. That's still easy this way. It's not that bad, actually. If you remember, if you having your formula sheet and convert secant square into tangent square plus 1, minus 1, and 1 cancel out, you only have tangent square over secant square, and secant square is cosine square. Then this is equal sine square theta over cosine square theta multiplied by cosine square theta. Then you cancel the cosine and you get the same answer. So we have 2 ways to do it. Yeah, well, exactly, because you can remember what's the secant is the inverse of the cosine. But if you're looking carefully, if this is really the other one is easier if you remember the formula. That's it. That's section. So they are very short. Oh, it's not here. Section 3, solving the trigonometry equations. That's very similar when we said sine x equals 0, x was equal m pi. That was the solution, right? That was the solution. Now, if we say you have 2 sine of x equal 1, what is x? Well, you say I divide by 2, then I have sine of x equal half. What angle is that? The sine of x equal half. If you go back, you can use your calculator. Can you tell me what is sine of x equal half? Just put sine inverse of half, you will know the angle. Should be 30 degrees. What's the sine inverse of half? Okay, x equals sine inverse of half. 52, 0.52. Well, you got it in radian. Can you divide? Basically, in radian is pi over 6. Divide this pi over 6. How much is that? Should be 0.52, whatever. No? Okay. So we kind of like, you need to figure it out. Basically, it's pi over 6. You remember those circles, they show all the angles, pi something, and they're, so you can go back and look at them, then you can figure out which angle it has the sine of it is 1/2. So it is pi over 6. Well, but there is another, a lot of times there is 2 angles, not 1. Because remember when we say sine of 0, we have 1 on the right and 1 on the left. We're gonna have the same thing. Okay, well, let's see. I'm gonna do the circle so you understand it more. They don't show the circle. Very easy to understand the circle. Okay. If this is sine again, and this is cosine. And remember, this is always 0, 2 pi. This is here also pi over 2 as an angle. This is pi, and this is 3 pi over 2 as an angle. Now, if I have pi over 6, it's gonna look something like that. This is pi over 6. What is the other angle has the same sign? If I go, where is the sine value? This is the sine value. This is a half. Right? This is a half. This is the number half. This is half of the radius. Oh, my scale is not the greatest. Now, if I continue to the other side of the circle and connect back to here, that's the new angle that have the same sign. So if you start from X, go all the way to this line, that's the new angle. What is the value of that angle from here to here? Can you figure it out? So if this pi over 6, this also pi over 6 because it's symmetric. Then this angle equal pi minus pi over 6. That will give you 5 pi over 6. So this is the other angle, the sine of it is half. So I'm gonna write here sine pi over 6 equal half. Sine 5 pi over 6 also half. But remember, this is right now our reference angle. I can add many revolutions to the answer. If I have 2 pi more, I will go back to the same location, right? If I said here, the pi, this is 6 here. If I said pi over 6 plus 2. Well, let me write n2 n pi. N is number of cycles, and the cycle is 2 pi. So that angle will be the same while going around and around and around. It's the same angle. So pi over 6 plus n2 pi. The same thing for 5 pi over 6 plus n2 pi. So that is the solution. So x equal, that's one solution. There's another solution here, x equal. Let me write it down here. Pi over 6, this is 6. Pi over 6 plus n 2 pi. Those are two solutions for the problem. Okay, most of the time you're always going to have two solutions. You draw the circle, you figure out those two solutions. So here we go. See, this is, they say, that's the first solution. They said 2m pi. I mean, it's okay to write it this way, but to me, it's easier to say n2 pi because the 2 pi is one cycle, n number of cycle. Okay, always remember, n number of cycle, 2 pi is one cycle. So that's the solution for the problem. So they're showing it here now, okay? So that's a circle. Pi over 6, sine pi over 2m pi equal half. The same thing for this angle. But they didn't tell you how they figured it out. Because this is pi here. And this, we said pi minus, and this is also pi over 6. We said pi minus pi over 6 give us 5 pi over 6. Okay, let's, for sake of argument, if we have similar problem, cosine x equal half. How do you figure it out? The solution for x. You draw the circle, right? That's the same problem. I just changed it to sine. Cosine, sine, this is 0. This is pi over 2, pi, 3 pi over 2 as an angle. That's 2 pi here. What is the angle? If you go back to that circle again, what's the angle? It's cosine equal half. If you calculate, it's going to be pi over 3. Okay, pi over 3, basically it's 60 degrees. What is a pi over 3? It's kind of like this much. This is pi over 3. Well, this point on the circle, the projection on horizontal, this is the value is half. That's the cosine. What the other angle that have the same cosine? How do you figure it out? The same cosine, well, that's the cosine. If I go down, like we did with the other one, Basically, if you want to make it simple, basically it is negative pi over 6. That has the same sign as pi over 6. Now, if we add complete revolution, then x is equal pi over, why I'm saying 6? This is 3. Sorry. Pi over 3. X equal pi over 3 plus 2n pi. Same thing like the book. Also, x equal negative pi over 3 I don't know if it works that way. Just a minute, let me think about it. We said if I adding negative 2, if I add 2 pi actually I can make it, let's see what the book did. So you can say negative 2m pi. So what happened, you're going one revolution backward. So this current here will be in the same location, 2m pi. So what we're saying, if I'm here, negative, if I go back around by one revolution, I'll be in the same place. As long as I'm coming back to the same place, that will give me the correct answer. So it can be done positive if I calculated this angle. If I calculate the whole angle, that's how much is that angle? That's 2 pi minus pi over 3. So how much is that? That's 6 over 3, 6, that's 5 pi over 3. Then I can say x equal 5 pi over 3 plus 2n pi. This is all the same thing, one going forward, one going backward. But if you have a habit, always do it positive would be better. Oh, there is no solution for this problem in here. So let's look at, so I just created this one. Okay. To kind of sine and cosine. So now they are asking us to solve this problem. What is x? Question mark. Sine of x plus square root of 2 equal negative sine of x. Well, I cannot solve it that way. I need to isolate the sine of x, right? So that should be written sine of x. If I move this one to the other side, it becomes positive sine of x. Okay. Now I want to move the number to the next side. It becomes negative square root of 2. So we're moving this number to this side. Now this has become 2 sine of x then divide both sides by 2, you get sine of x equal negative square root of 2 over 2. If you use your calculator, or if you go back to the circle to do it like the book, this is basically I think this pi over 4. So this angle, negative pi over 4, if I take the sine of it, that's this length here is negative square root over 2. So that's the sine value for this angle. Well, what's the other angle? I have to do the reflection, pi over 2, pi over 4, and well, it doesn't seem I have, if I do that, I get positive. So it doesn't work that way. Oh, so how do I find the same sign? How about reflection about y this way? So reflection about x did not work, but reflection this way, it will give me, so basically now I need to know what is this angle. Well, basically this is, if this is pi plus pi over 4, okay, so pi plus pi over 4, how much is that? Pi plus pi over 4, that's 4 over 4, that's 5 pi over 4. So this angle, 5 pi over 4. Five pi over 4. Well, negative pi over 4, can I make it positive? Instead of negative? Yes, we can. How do you do that? Because this is negative, always I have to start from here. So basically this is 2 pi minus pi over 4. 2 pi minus pi over 4. Again, this becomes 8. That's 7 equals 7 pi over 4. Now we find the coterminal angles. I have one angle 7 pi over 4 and another angle, where is it? 5 pi over 4. Then what is the solution? X equal 5 pi over 4 plus 2n pi. The other one, 7 pi over 4 plus 2n pi. You can see it's almost always we have two solutions. You have to do the drawing in order to figure out those two angles. Otherwise, it would be really hard. Or if you go back and look at the circle with the angles and stuff like that. Okay, this is, yeah, so that's, you can see in the book, they just says as a solution. Figure it out. Where does this come from? If you read the book, you have a harder problem understand where these come from. Correct? So with the circle, you draw the plot the angle, you know what you're looking for. Always your positive angles start from the x counterclockwise. Equation of quadratic type. Same thing, but this time, if I have an equations like this, 2 sine square of x minus sine of x minus 1 equals 0. What is this quadratic equation? You can imagine this is as one piece. It's like x or something. And this is A and B and C. So what they did here, like remember that when we have in that chapter of the E equations, when we have e to 2 power e2x, we say this is equal ex to power 2. It's the same thing in here. So we can say that we convert. You don't have to really convert this. Obviously, this square. So we could, if I have to solve this problem, I say I can FOIL out. I write sine of x here, sine of x here. Two number, if I add them -1, multiply them is -1. That would be hard. There is. I cannot do that. I have 2 in here. So then we have to use the quadratic formula, which I cannot, or let's do it differently. Remember, I have to, this is 2 sine of x, and this is 2 sine of x, because there is a 2 in front of it. Now, if I multiply 2 by -1, 2 multiplied by -1 is going to give me -2. So now I need 2 numbers, a plus b equal -1, and a times b equal -2. What are those 2 numbers? You multiply them -2, you add them -1. -2 and +1, correct? So 2 number, you multiply them -2, you add them -1. That's the -2 and 1. Now what you do, you say the first part equal to 0, the second you have 2 solutions. One solution, 2 sine of x minus 2 equals 0. Then you continue isolating the sine of x and or 2 sine of x plus 1 equals 0. Then you're gonna get 2 solutions from each one. A lot of solution. Let's see if they solve this problem. Yes, they did. They didn't tell you how they get from here to here. So we have 2 sine of x plus 1. I did have 2 and 2 here, which doesn't matter. They can be canceled out. Remember, you can factor out the 2 and get rid of it. Even if it's there, it doesn't affect anything. Then from here, you have 2 sine of x plus 1 equals 0. Then you say sine of x equal -1 divided by 2. Now we're back to the square one. We know how to do this one right now. We need to figure out what that angle, what the angle, the sine of it equal -1/2. We learned before that pi over 6, sine of pi over 6, how much? Is half, positive half. Then sine but I have -1/2. Is sine negative pi of 6 equal negative half? I think it does. Yes, because the sine is vertical. Then you draw your circle. You say if this is pi of pi over 6, that's the negative part. And this is a pi over 6, the positive part. And you see here, the sine of this one negative half, but this one is not. The other angle should be coming from here, like we did it before. So you have to calculate the angle all the way around. So this one from here to here, what's that angle equal to? Pi plus pi over 6. Because this angle here, pi over 6 too. So if I say pi plus pi over 6, it will give me 7 pi over 6. That's the first angle. The other one, I have to go all the way around to here. That's basically 2 pi minus pi over 6. 2 pi minus pi over 6. Then you get here 12, that's 11 pi over 6. Now you can add to each one plus 2m pi, plus 2m pi, you get the solution for the first one. So here we go. See, here's the solution. That's the solution. That's what we find out, right? We said 7 pi over 6 and 11 pi over 6. And the other one, sine x minus 1, then you get sine x equal 1. Well, sine x equal 1, that's the only solution here. We have only one solution. There is no symmetrics. It's pi over 2. Why? Because this is a sine, and also here pi over 2. So this is the value 1. So sine pi over 2 is 1. There is no symmetry. It's on the sine, on the axis. There is no symmetry, nothing. So only one solution, pi over 2. Okay. Solve for t. T question mark. What you do, isolate first. The cosine of 3t. So 2 cosine 3t equal what? Equal 1 by moving the 1 to the other side. Divide by 2. Cosine 3t equal half. Oh, didn't we solve this problem a minute ago? So assume x equals 3t. So we say cosine x equal half. What was the solution for this one? Let's go back. Where is it? No. Oh, that's from previous section. I got lost. Okay. Yeah, it's not in this section. Okay. Remember, cosine of half, the half is cosine of pi over 3. Okay, we did the circle like that. This was pi over 3, and this is the cosine. We went to continuously down. So this is pi over 3. We added to it, we said 2 pi minus pi over 3 to give us the other angle. So this is the first angle, pi over 3. The second angle, 2 pi minus pi over 3. We say that's 6, this is 5 pi over 3. So now we're going to say that instead of x, I'm going to put 3t equal the first angle is pi over 3. If we have here plus 2 n pi, now multiply, divide by 3 both sides, you get t equal pi over 9 plus 2 n pi over 3. So that's the first one. Well, what we did divided by, the difference is we divided by 3. The other one, 3t equal 5 pi over 3 plus 2n pi, divide by 3, you get 5 pi over 9 plus 2n pi over 3. That's it, we got the two solutions. Really, if it doesn't matter if it's x or 3t. At the end, you divide by that number. This process is the same. Here we go. So that's the two solution we just got. Okay, divide by 3. That's what happened. That's a similar problem. And this is, you have, they start with the secant square x minus 2 tangent x equal 4. We converted this to be tangent 1 plus tangent. That's equal this one. 1 plus tangent square x minus 2 tangent x. We brought the 4 to this side, minus 4 equals 0. Then that's the equation now we can solve. This looks like a quadratic equation. See, square, not square, minus 3. So I can do this. Tangent here, it's like saying x here, tangent here, tangent here. Now two number, a plus b equal -2. A times B equal -3. What are those two numbers? This would be there is only one option that -3 and +1. If I multiply them, -3. If I add them, -2. That's equals 0. Then again, we have two solutions. We're going to go back to the circle. Tangent -3 equals 0. Then tangent x equals 3. Then need to figure out what's the angle. It's the same thing. You have two solutions. Then tangent +1 equals 0. You get tangent x equal -1. What does mean arc tangent? Have you seen this before? Arc tangent? Have you seen it before? Okay. Here, what is the x? Is the that's what you're using in your calculator, tangent inverse over 3. What the x here? Tangent inverse of -1. Well, some books, they say instead of tangent inverse, that's equal arc tangent. That's the same meaning. But calculators, they don't write this one. It's too long to write. But a lot of books, they use arc tangent instead of tangent to -1. So you can use your calculator, but you're going to get decimals different from their answer. Okay, listen. Tell me, what is the tangent inverse of 3? Use your calculator. Get it in radian. Make sure your default is changed to radian, not degrees. Do you know how to change the default of the angles? What did you get, Maria, for tangent inverse of 3? 1.24. Well, this is radian. If I ask you how many pi is that? Okay. Divide pi over 1.24. Divide whatever you answer, say pi divide by that number. 2.5. I was hoping getting some. So basically is 2.253 over pi. No, doesn't work that way. Yes, yes. So kind of like inverted it. So now if I do pi over this number, should give me 1.24 radian. So this is how many pi. I don't know, this 1 point, this could be looking something else, could be square root, some da. Well, let's try it with other one. What is the tangent inverse of -1? How much is that? Negative 0.79. Okay. John's now say 2 pi, I mean the pi divided by this. That's giving you, then inverted, you can find it. So I'm trying to help you, like if you need to figure out how many pi's. So this is radian, right? This is radian, but how many pi? If I divide pi by this number, that would tell me how many pi. Then divide by that number, we get it back. The same way I did here. Well, in the books, they assume you know that circle. So if you go back to the circle we have with all angles, you can figure it out directly over there. Well, it came up, the one over -1 is negative pi over 4 plus m pi. But the other one, it seemed like this fraction is not known. Although they said arctangent of 3 plus m pi. So I didn't want to do it hard. Why is it not 2 m pi? It's m pi. Because I think if you look at the circle here, this is pi over 2, and this is 3 pi over 2. And if this is pi over 4, and this is pi over 4, negative. Most of these, they have same cosine, but they don't have the same tangent. What is a tangent? A sine over cosine. Remember we said the tangent here, cosine, and this here, if you have sine, cosine, tangent, all of them positive. But because this side, the cosine is negative, so the sine is positive, the cosine is negative, then the tangent is negative, this tangent. Here, you have this, the sine is negative, cosine is negative, then the tangent is positive. Here you have the cosine is positive, the sine is negative, cosine is positive, then the tangent is negative. So tangent positive only in quadrant 1 and quadrant 2, and negative in quadrant 3 and 4. Okay, so if the tangent's negative here and here, that means this angle over here have a negative tangent. So basically that's the reason half, if I go half of the revolution, will get me to the angle have the same tangent. So we went half, 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 half. So what section is that? That's section 3. Let's see, section 4. say sum and difference formula. But again, this is more formulas. You don't need to, where these come from? It said here, sine of u plus sine of v equals sine cosine plus cosine sine. Again, you have these formula in your formula sheet. Then sine minus sine of v, sine cosine, minus cosine of u, sine of v. This is basically if you're having adding two angles or subtracting two angles and try to figure out what's the sine. So you don't, you have to split them into much useful way of using it. Tangent more complicated. Tangent u plus v equal tangent u plus tangent v over 1 minus tangent u tangent v. Remember where we use this formula, right? In chapter 10. Because tangent is the slope. Remember that m2 minus m1. So we use this formula in chapter 10. So this is called sum and differences formula. Find the exact value of sine pi over 4 over 12. Again, they're trying to use the circle. I can use a calculator to find this one, but they want to try to get it as a term of pi or find the exact. See, the calculator is not exact. It's always approximation. So they converted pi over 12 into pi over 3 minus pi over 4 because I know what the sine of pi over 3 looking back into that circle. So I should have got that circle. I don't know what section was those circles is. I will look at them in a minute. So now if you say sine of this pi over 3 or minus pi over 4, what was the formula? They said sine what was it? U minus V is sine cosine minus cosine sine. So that should be sine of pi over 3 multiplied by cosine pi over 4 minus cosine pi over 3 multiplied by sine over pi over 4. Where did I get this from? That's the formula they just, we looked at in here, page up, this formula. Sine cosine minus cosine sine. That's what I used. Just straightforward application. Okay, as we say, sine cosine minus cosine sine. Now I can plug in the value for each one, the exact answer. The sine pi over 3 square root 3 over 2 square root 2 over 2 for the pi over 4 minus this is half square root 2 over 2. You just simplify it to get the exact answer. Well, this is easier to take care of. Now, this said use the difference to prove this function is correct. So we have to prove this. Don't touch. Well, we have cosine minus pi over 2 minus x. What was the formula? So we should have the formula with us. So let's go back, look at the cosine u minus v. If we look at the cosine u, here it is, that's the formula. Cosine u minus v is said cosine, positive sine. So that's the formula we have to use. Okay. So basically we said this is equal cosine pi over 2 cosine x or plus sine pi over 2 sine x. Based on that formula, when they said cosine u minus v, that equal cosine u cosine v plus sine u sine v. What cosine pi over 2 equal to? If you look at this is in your calculator, this is 90 degree. The cosine of this equals 0. What's the sine pi over 2? That's equal 1. The sine pi over 2 is equal 1. Then what we're gonna get here, 0 is gone. The final answer is sine of x. Oh, check mark. Correct. That's very easy to prove. Find all solution for this. We have sine. Something is not right in here. What kind of parenthesis is this? I think what they meant this way. We'll double check that. We're looking for sine of x plus pi over 4, sine of x minus pi over 4. Then we use those formula. We look back on them and solve the problem. So this part here equal to this one. Okay, this one, this part. Sine x cosine pi over 4 plus cosine x sine pi over 4. So you have to go back to those formula to verify this is correct. Then this part here, this one. It said sine x cosine pi over 4. But see here, when positive, we got positive. When negative, we got negative. Same, almost same formula. That's equal -1. Now, what is the cosine pi over 4 equal to? This is, you can use your calculators, and I think we can get the answer. This is not 0. Cosine pi over 4. Basically, one thing, okay, go ahead and calculate cosine pi over 4 and sine pi over 4 and tell me what do you know? What do you find out? If you're using degree, is 45 degree. Pi over 4 equal 45. What do you find out? Just find the sine of 45 and cosine of 45. What do you find out? The same, yes. So we know they are the same, then they're gonna cancel out because they are repeated everywhere. If they are the same, they're gone. So you're gonna get here sine of x plus cosine of x plus sine of x minus cosine of x equal -1. Now cosine negative, cosine positive also gone. So we get 2 sine of x equal -1. Then sine of x equal -1 over 2. I think we already solved that problem. We know how to do it with the circles and the pi and all of these stuff. I don't know what they did in here. Well, they did it differently. That's interesting. What they did in the book, show you what they did. See what we did also, perfectly correct. What they said, I have here negative cosine sine pi, I have here positive. Then they cancel out. Okay, then what you left, sine cosine, you're gonna get 2 sine x cosine pi over 4. Now they evaluated this cosine with a square root of 2 over 2. So they said here sine x, 2 sine of x, that's square root 2 over 2 equal -1. Then you isolate all of these numbers, you get different solution. I think both of them are correct. So we end up with sine x is equal -1 over square root of 2, but still both of them correct. Okay, let me show you where are. Do you have your book? Look at chapter 4 and find like in section 2 or 3, those circles. you find them? And dots, there is multiple circle, not one, maybe at least we have 4 of them. One for the pi over 4, one for pi over 6, and one for pi over 6. So there are 3 circles at least. What sections they are? 4.2. Yeah, okay. So this is your first circle. Here, this is for pi over 4. You know that the first angle, how do you read this one? So they show you the angles. So they are cannot in sequence. This says 0 angle. This is the 0. 1 and 2. The cosine, remember the first number cosine, comma sine. So for the angle 0, cosine is 1, sine is 0. Now the next angle pi over 4, that is pi over 4. And this is cosine, and this is sine of it. Then you go to the pi over 2, 0 and 1. So this is this angle pi over 2. Then you say 3 pi over 4, this is the angle. So you can always start from here. So you keep going this way, this way, this way, then you get all the angle from 0 to 2 pi. You always start from the x. So you go from here, maybe to here to get this angle. You go from here to here to get this angle. And they show you here the cosine and sine. Same things. This is for pi over 6. 0, pi over 6, pi over 3. And actually just 2 of them. So really there are 2 circles only. So this one combining pi over 6 and pi over 3. And you can see all the answer. Whatever. Then if you get whatever number for cosine, you come back and look for it here. So we need to somehow, I'll print those circles for you so you can always have them. You need to have them as a reference to help you out while you're solving the problem. That's the place what I'm referring all the time, circle, circle. Okay. I don't know, they have them again here, but the other 2 circles is much better. I have one practice for this chapter. That's one. I think you can solve all of these at this time, I think. Okay, so there is two questions on the top that said verify. Okay. The other two you solve for X. I'm gonna make this due Thursday evening. So if you have a question on Thursday class, I will help you out. Okay. Or maybe make it a Friday evening. So we'll please work on this problem. And if you have any questions, we'll look at it. One thing you could do, you just go back to the lectures. I'll try to make it publish shortly after it's become available. You can go back and look to similar example and solve the problem. They should be not too hard. Okay. All right, we'll stop here. I think that's enough for chapter 5. Yeah, we did a lot today. Please, I know it's whatever you have to do tonight, sit down and review them.